Hi everyone. Students, in today's lecture we will discuss about Wein's law. But before getting into more details, let me tell you something interesting about the stars. Students, when we refer to a star by calling it scalar, then what does it mean? We have learned that electromagnetic radiation or light is a spectrum, visible light being just one portion of it. What we call blue is just an even smaller portion of the spectrum. So students, instead of simply calling it blue, we could define it in numbers because as we know that light is characterized by its wavelength. Blue light has a wavelength of about you can say 450 nanometers. So when we refer to a blue star, what we are saying is that much of its radiation is coming from this portion of spectrum. Just like the filament of a light bulb, a star's light is produced by incandescence or formally a black body radiation. We know that black body radiation is temperature dependent. The hotter the black body radiator is, the brighter it will be. This is why colder stars appear dim and red, and hotter stars are brighter and bluer, as represented by this diagram. The hottest stars in the sky, blue hypergiants, are upwards of 40,000 degrees centigrade and can shine about 5 million times brighter than our sun. We say that hotter stars are blue and the colder stars are red. But reality with black body radiation is that every star produces at least a little bit of every color of the spectrum. When we say that a star is blue, we are saying that the majority of its radiation is being produced in this portion of the spectrum. This majority exists because each blackbody emitter has a spectrum that is peaked, meaning there is a wavelength at which the star produces more light than at any other wavelength. These peak wavelengths are directly related to the surface temperature of a star, and this is actually a Wein's law. This relationship is described by Wein's law, which takes the form of the equation, and the equation is given by delta maximum is equal to 0.0029 mk, that is divided by T, where lambda maximum actually represents the peak wavelength. We can also represent it graphically. Here peak represents the wavelength of visible light. Students, despite having more material to burn, more massive stars live shorter lives. Blue stars are rogue stars that live fast and die young. Red stars live long and much more uneventful lives. The sun's spectrum peaks at a wavelength of about 500 nanometer, which is greenish, as represented by this figure. And it appears whitish or you can say yellowish to our eyes because it is emitting a lot of light across the entire visible spectrum. Students, this is all about this lecture where we have discussed about Wein's law and also discussed its explanation. Thank you so much.